real exam questions. This is question 15, Ultimate Limit State General. Below is an expression in dimensionless units. Prove this equation. When is this equation valid, and what is its physical meaning? First, we will prove the equation. Consider a section loaded with an external bending moment md. The compressive force Fc is equal to the fill-in factor C times x, which is the depth of the neutral axis, times FCD times B, the width of the concrete section. So that's the concrete force, and it must be in equilibrium with the tension force in the reinforcement. So the force in the reinforcement is, of course, the stress in the reinforcement times its total area. The distance between those two is the lever arm Z, which is, of course, the effective depth from there to there, D, minus delta Gx, and delta Gx is just the coefficient giving you the point of gravity of the force Fc. Now we look at a rotation equilibrium. So the acting bending moment must be equal to the resisting bending moment. So the acting bending moment is md, and the resisting bending moment, we will take bending moment around the tension reinforcement, is Fc times Z. You can also take a bending moment around Fc, you will arrive at the same kind of formula. Fc, we've seen, is a filling factor times x times Fc times B, and Z is D minus delta Gx. So we got this. Now we have to make dimensionless units from of it. So we divide by BD squared FCD. We do that the same with this equation. And then we got this. And x over d is, of course, c, which is the depth of the relative depth of the compression height of the beam. Now let's look at the following expression. We still need to find z. Z is d minus delta Gx. Z over d divided by d is 1 minus delta Gx over d. X over d is c. So zeta over d is z over d, and c is x over d. So we see that zeta, the lever arm, is equal to 1 minus delta G C. We have now the two equations, this general equation plus this equation, and it gives you the formula, because you substitute this and that we need to prove. When is this valid? When is this now valid? Well, the relation, of course, is always valid in domain 2A for single bending and single reinforcement. We did not use the compression reinforcement, and we did not use an external load to it. So it's only domain 2A that this is valid. And what is its physical meaning? Well, total bending moment is equal to the filling coefficient times the height of the concrete pressure diagram times its lever arm. Or you can say this is the force in the concrete multiplied by the lever arm is the total bending moment. Simple as that.